Welcome back to another Circuit Playground Express Circuit Python video. And today it's gonna be, I want to test out just how breadboards work, and how basic kind of functions like LEDs, let me show that, and like resistors and switches and buttons, how those work, as well as digital input signals. So these are kind of getting a little bit more into advanced territory just because sometimes Circuit Playground has a lot of features, it has a lot of nice capabilities, a lot of sensors packed into it, but there will be times where I think I will need to, use a little bit more of those sensors, and use sensors that are not included in Circuit Playground Express. And so I just wanted to make this video to explore how to use the breadboard, by kind of creating a game where you would need to press buttons for different lights to kind of make a secondary color, so red, yellow, and blue, and then by pressing the like which button it is, you would be able to make that, I guess, secondary color. And it'll make more sense as we go. So let's get started. Alright, and so in order to really understand how the buttons work and how all the pinouts work, I first created a program that whenever you press the button, it lights up LED values, and then it lights up more LED values as you press the button for more time. And here's kind of what that was. So there were, in the CircuitPython file, first, of course, we import all the packages, Circuit Playground Express, the board, which basically allows us to discover all the different boards and the pinouts in the board and be able to reference them, digital I/O, which is something that allows for digital input and output, which will be really helpful in understanding when the button is pressed, and then of course time to allow us to wait. So here, this is the really important part. We create 4 digital pins, and if we look at the Circuit Playground Express, these are the A1, A2, A3, and A4 pins. And so basically what this would look like is these A1, A2, A3, A4 pins, those are analog pins, and they also have digital values associated with them as well when they function as digital pins. And those values can be found as the purple numbers right here. And so to make it easy, I just labeled them D1, D2, D3, and D4. But on the board, of course, their values are different. The D1 pin, which is the A1 pin, is D6. A2 pin is D9. A3 pin is D10. And then the A4 pin is D3. So that's just something to keep in mind. These here is just referring to digital, and then this is referring to the A pin number that's shown on the Circuit Playground Express, just to make sure that there's no confusion between this number and this number. And then I just basically set count to 0, and then I get D4.value, which basically just tells me whether it's on or off, kind of like a light switch. And here you'll see that D4 is the only pin that has input, the rest are output, which means that D4 reads digital values, and it reads basically saying outputs a value if it's true, if it's at a high value, which is when it's true, and if it's at a low value, which is when it's false. So we read that to see basically when the button is pressed. And then we wait for 0.15 seconds just to make sure that there's enough time for inputs to be received and also to graph it. And if the button state is true, that means basically if the button is pressed, count plus equals to 1. And basically if count is equal to 4, then we reset the count. So when count is equal to 0, all of them are false. which means that there are no digital outputs being sent to any of the pins, through any of the pins. If count is equal to 1, that means the D1 pin sends a true value. Count is equal to 2, D2 also sends that true value, which means now there's a high voltage being sent to the LEDs, lighting them up. And then D3 value being true if count is 3, again, high voltage value. And then it just prints it just to make sure that everything is working smoothly. So that's kind of how the code works. And now I'm just going to download it real quick just so you can understand how digital inputs and outputs works. This really helped me when actually developing the real button system for the game, and allowed me to troubleshoot through many of the just board values that I wasn't really familiar with while working through it. Alright, and here we have it. Here is our breadboard. This is the test that really allowed me to understand how button inputs work, and this is the code that I just showed. So, quick kind of just overview of the electronic circuitry. Here we have our ground and our volt, so voltage comes out of here and it goes into here. This is our A1 pin, our A2 pin, our A3 pin. These are all output pins. And then our A4 pin, and we kind of discussed this a little bit with the code. So where do they all go? Well, our pins over here, the V out pin, which we saw here, goes into the positive place. And then the ground, which is over here, the negative, goes into the minus. And what this does is this basically allows for that positive or negative charge to carry through this breadboard right here. And let's first talk about the LEDs. So these are two separate circuits. They do have current flowing through them, but they work separately. So as you can see, the LEDs, three LEDs here, A1, A2, A3, those are all outputs, meaning they all send their voltage through here, go through a resistor that has a positive signal, and then get completed with ground, so we have a complete circuit there. And then we have our second circuit here, which is the button to get the values from. And here we have a positive signal going up, and then we have a connector to the A4 pin over here, which basically shows whether or not it's this button is pressed. So when the button is pressed, it'll allow for what happens, the voltage in this column to carry into this column, which would give this a positive signal. And then that's when the button is closed. However, when the button is open, there still needs to be a complete circuit, or else this input value right here will not be 0. It will not be a low state. It'll kind of be in an indeterminate state. So what we do is we connect a resistor to the ground value, which basically just shows that it is now connected to the 0 or the ground, and allows to for us to provide a value to the A4 pin when it's not running. So that's all the kind of explanation of the circuit. To now describe how it goes, we have our input of the button when it's pressed, and then there, as you can see, the LEDs light up. So when I press it once, the green lights up, press it twice, yellow lights up, and there I kind of held it too long. The white would also goes up, and if you don't want that to happen, you can increase the wait time between inputs. So there we go. And there we go. It's working pretty well now. So that is kind of just how this works. And now I think you'll see how I apply these concepts into our actual kind of breadboard. All right. And so now it's time to just quickly discuss the code for the actual game. It's very similar to the test in that we create the 3 digital input pins. This time we don't really need digital output pins because the current kind of deals with it itself. We set the brightness to 0.3, and then the computer is true, which means it starts off with the computer's turn. The combination is false. Basically, that variable just says whether or not there's a combination of two different colors. That's correct. And then green, purple, and orange variables are all false. So we have two rounds here. The computer, which basically picks a random number between 0 and 2. And if the random number is 0, it's green and it flashes green. If it's 1, it's purple and flashes purple. And if it's 2, it's orange and flashes orange. Then it rests for 2 seconds and then sets the computer to false and clears the pixels. So very easy stuff. Not really too complicated on the code here. And then else, we create a start time, and we basically say while you're in between 3 seconds of that start time, and you don't have a combination yet, if it's green, if the D3 and D4 pins give you true values for both of them, basically saying that they're on high, which means the buttons are pressed. These are yellow and blue, so that would mean that the combination is true. And we can set green to false now, and it's the computer's turn. And then if it was purple, then D2 value, which is red, and D4 value would both need to be pressed. Same thing in orange, D2 value red, D3 value yellow. So it kind of just goes through there and then sets the combination to false at the end, just to make sure that this right here can reset as we're going through the while loop, and just keeps on continuing like this until you really miss kind of choosing that color in those 5 seconds. So yeah, that's the code. I hope you learned something from it. Really just using these input pins, then reading the digital inputs and outputs was the main goal of it. So yeah, let's see a quick run through. And now it's time to demo the game. So it really is a reaction game. Circuit Playground is going to first give a light, and then after that, I'm going to press the buttons basically corresponding to each of the primary colors. So let's start it up. Alright, so it's orange. Press the red and the yellow. Alright, now next one is purple. Let's get that one. Alright, we're good. Green. Purple, and I'm doing this on the phone, so it's a lot harder while holding the phone. So as you can see though, it's very responsive to the touches after the lights stop shining. And then here I'll just kind of demonstrate, and then I'll do 1 or 2 more. It's pretty fun. Also seeing how they just light up is amazing. So yeah, this is a pretty simple kind of thing to put together, and now as you can see, the game has ended. Pressing any of these won't really do much, except for it does, which is something that I might have to look for in the code, but I don't think it really takes away too much. Maybe it wasn't in the 5 seconds either. Let's see. Okay, maybe that's something to look into, but for the most part, right here, just looking in, we have a voltage and a ground output put on the edge of the breadboard like we saw last time, and a ground on this side as well. Basically, the voltage sends it through here, which when connected with the button creates, oh see, now it's not working. Like I'm just pressing this and it's just not working. So it goes through the button, which then connects the resistor, lighting up the LED. Also, whenever the button is pressed, it connects the output signal to here, which is connected to ground as well through resistor as the base value. So it's a lot of basically what I used in the test and what we saw there, but just adding a little bit more complexity to it, creating a parallel circuit with 3 different LEDs here, all connected to their respective buttons. So yeah, I hope you enjoyed this video. It was really fun to learn about breadboards and how much they can really hold and how much power they can hold, and voltage outputs as well. And yeah, stay tuned for future episodes. Peace.